Hi, Simon here, GM8NYV, continuing on with the restoration of my CR100, which is nearly completed. Well, the electronic side of it is anyway. Still the case and the front cover to repaint and relabel. Now, I haven't done much lately, had other things to keep me busy, but I managed to do a little bit more today. One of the things that was holding me back was the ganging tool. Now, I made one out of an old telescopic aerial and a box spanner, and I found the coils underneath in the coil pack. The flats weren't filed very prominently on them, and the telescopic aerial just didn't work. So I bought myself a piece of brass rod, proper brass rod. It's 4mm in diameter, about 3mm centre, and basically that's it. I cut it. It came in a big length. I've got two actually. It's this length here. So I cut it in half and I stuck it on the screwdriver. I glued it on with a bit of tape, and then I've got a slightly different box spanner, so that would go in. So now that's my ganging tool, and it actually worked. So I completed the alignment of the HF coils and the oscillator coils there. Basically just continued, and I've sealed them all up, so that's not too bad. Right, the last thing I had to do was the output filter for the 100 Hz side. It says 100 Hz filter. It's not actually 100 Hz. It's 100 Hz wide at, I think, about 1 kHz. Now, according to the book, you set it up at 950, and there's a set of drawings and a plot which I was hoping to try and match. Anyway, in the meantime, I was using my fluke through a resistor on milliamps to try and get connected to the output as an output meter. But what I saw on eBay, surprise, surprise, suddenly for about £10, I think it was £7 and £10 postage, was this. An actual Marconi output meter. It's a TF350. There's quite a weight in it. It's quite a big thing compared to modern stuff. But what I like about it, it's got a nice big dial on it, calibrated in milliwatts and decibels. You can, on this side here, you can change the impedance. Then there's a meter multiplier, another. That's the impedance multiplier down here. And then you've got the two inputs here. Now then, let's have a quick open up, have a quick look inside it. Right, it's held on with these 6 little chrome thumb screws. So we're going to open this carefully. There we go. Right, quite a heavy thing this. Let's move the case out of the way. It smells old, musty. And there we go. It's a completely passive device. It has no power supply or anything like that. No amplifiers or anything. And you can see here the big matching transformer. These like waxed resistors are all, I don't know how accurate these resistors are now. And coils on this one, switched coils, a few resistors, nice big meter here, and this metal plate is actually, I measured it earlier, it's actually 4mm thick. It's like something you make a tank out of probably these days. Now what the other thing is, let me pop that up not to damage the insides, is the case. It's just a metal case, but I'm not sure. I had a scratch of this. See, it looks like copper. I'm just wondering if the whole case is copper. I'm not sure, or they've just put copper on the outside there. I got a feeling it's just painted copper on there. It doesn't sound like copper. It's quite heavy really for copper. So this is what I'm going to use. I'm going to try this to set up the CR100's 100 Hz passband filter. This is the output meter, new output meter. I did do this before with the, as I said before, with my Fluke, and I think I got roughly the same results. Yeah, it's calibrated in milliwatts, as you can see there. Not really interested in the actual milliwatts itself, but at least it gives me a scale. I can go down to the half power mark. Connect it to the actual loudspeaker output, and I've set this to about 150. I think that was the closest on the impedance matching there. Over here I have my signal generator. It's a bit bright there. I've set it to the 950 Hertz as recommended in the setup manual. There's a 950 Hertz here. I've got an amplitude of about 1.4 volts, and the output is fed. They said using an attenuator, so I'm not bothering with the attenuator because I can change the amplitude. So I've got it connected via this capacitor, 1.1 UF capacitor, onto the grid of valve 8, and according to the book the gains are set high. Switch it on, so I'll switch this on here. I'll let it warm up. Switch on the output of the signal generator at 950, and there, what I'll do is change the amplitude, try and get onto the 20 there, just as a reference. So I shall move the amplitude, up, just so I've got that as a reference there, so I can peek it. Now according to the book, I use a 100 K resistor, which is this. Okay. And you clip it across. There's the 100 Hertz filter here. As it's not actually filtered in 100 Hertz, it's 100 Hertz wide at 1 kilohertz. But according to the book, the setup at 950. So this is the input side, that's the output side. So I've got one side of my resistor clipped to the ground, and it says, first of all, short out the second section. Right, so that's the second section sorted out, and then we tune this capacitor using my new ganging tool. Obviously the output meter has dropped there. I'll increase the amplitude a little, just so we can get some readings. I'm going to tune the first, it's a compression trimmer. So by basically unscrewing it, you're compressing it anti-clockwise. So I'm looking for a peak at 950. Now it's gone past the peak. Start to go down this. So that's about peak there. I'll stop there. I'm just after a peak at the moment. I'm not really interested in the actual reading. So what I'm going to do is swap the resistor to the other one. Now it'll probably jump right up, so I'm going to change the multiplier down so it doesn't go off scale when I take off the resistor. I'm taking it off, the resistor off this one. I'm going to put it under that one there and tune this one. Now this is where I found I have a problem. I'll show you in a minute. So let's put this back down the range. Right, so I'll try and peak it around there. I've just increased the amplitude by a few millivolts. Now as I start to tune this one, turn it one way, obviously it goes down the way. Now to peak it up, which is there's peaking up, I'm now right at the end of the travel, hopefully on this. So there's no more movement, you can't open it anymore. And if I remember rightly, when I did this, the mica wafers in here were cracked, and one or two of them was snapped off, and I put some bits of plastic in. So that value of this variable capacitor is changed. Now what I'm going to do is tune about and see what frequency about the mid-range, and maybe set the other one to it. So it's still going to be 100 Hz. I'm going to put this back to the center position, or just near the top anyway. I'm going to change the frequency and see where it peaks at, and then set the other one to it. So let's go back to the meter and we'll start changing the frequency. Right, 10 Hz at a time. It's going down. So it's around there, it's going down. The beeping is the stepping it down in millivolts. Sorry, I'm changing the frequency. I think I passed the peak there. And I think that's the peak there, and that's at 941. Round it off to 940. And that's on the second one, so not 950, 940. I'll set it up to 940. I'm a bit moving the resistor now to the second capacitor there, and I'm going to peak up the first one to 940. Back on the first one there, which should be in its range, hopefully. There we go. So it's now, both of them are now peaked at 940 Hz, and not 950 as it's stated in the manual. What I'm going to do now is take off the resistor and set the amplitude to give me a full scale on here. After that, I'm going to reduce the frequency until I get half power, which is 25 milliwatts, from 50 to 25 milliwatts, and go in the other side direction and see what the pass band is at half power. Right, better not do that. Right, that's the resistor removed. I'm going to increase the amplitude now on 940 Hz. Yeah, full scale deflection on here, which on here is 15 millivolts. Now I'm going to mark the frequencies. Right, that's the center frequency of 940. Slowly decrease the frequency. I'm winding the frequency down now until I get to 25. Obviously, that's going to be half power, and that frequency is 889. 889 Hz. I'll go the other way, take it back up. Back to our 940. That's 940. Start to increase the frequency till we get back to the half power mark. Round about there, and that frequency 997. 997. Right, so the difference between 997, I've got down here now, 997. The difference between 997 and 889, which are the two 25 milliwatt points, is 108 Hz. So half power, 108 Hz wide, which I think is what they're looking for. It's not quite centered on 950 that they have in the book, but it'll do. I'm very rarely going to use that 100 Hz filter, really. in my use, but it's 108 hertz wide. It's not bad. Okay. Now on their graph, it's hard to see the 0 point here is above the peak. I've drawn it here, and it's a lot of little squares here. So there's roughly the 3 dB down mark from there. It's about here, so that comes to about 950, and then 3 dBs on the other side is about 1050. Coincidentally, as a textbook, it's 100 hertz, isn't it? So that's their response. But my response is not far off that, which I'm quite happy with. As I say, I'll probably not use the 100 hertz filter much. So that is basically the completion of the radio. Setting up anyway. I need to repair this now.